All right, we're in our second to last chapter or section, and this is 10-7, and this is special segments in a circle. Okay, and what we just did about the angles is pretty easy. People usually take to that very easily, and this is very similar, except that it's about segments. And so what we're going to say is when chords, secants, and tangents intersect, special segment relationships are formed. Now, what we did previously was when they intersected, we made these angle relationships. What we're going to do now is segment relationships, and there's three things that can happen. We can have two chords, we can have two secants, or we can have a secant and a tangent. Okay, so just like yesterday, we're going to make a little chart, a little table with three columns. Okay, so we're going to start by drawing our pictures. So we're going to put a circle in each one of these. And we're going to draw what we said can happen. So two chords intersecting in a circle. So there's one chord, two chords. We're going to do two secants intersecting in a circle. So and we're going to do a secant and a tangent. So here's our secant and here's our tangent. We're going to label everything again. So and then just like yesterday, we're going to write down the actual rules so that you have the picture and the rule, and then we're going to do an example problem. So when two chords intersect, they're always going to intersect inside the circle because they're segments and they're inside the circle. So their intersection always happens inside the circle. And the relationship that's formed is a proportional one. And the relationship is that AE times EC is equal to DE times EB. And so if you're thinking about how to memorize these, you don't need to worry about the letters. You just need to memorize that it's this times this is equal to this times this. Okay, so it's very basic. It's like a cross multiply and divide type of thing. Whenever we have two secants, the relationship is going to be that AB times AC is equal to AD times AE. And the reason that our picture with two secants has an intersection outside the circle is if the intersection was inside the circle, it would just be this picture over here again, and all we would care about is what's happening with the segments like this. So this is a different scenario than this. This one's a little trickier to remember. The best way to think about it is to think that AB is the outside and AC is the whole. And that's equal to AD, which is the outside, and AE, which is the whole. And when we do our example problem, the picture will make a lot more sense. These pictures are very abstract compared to what you're going to do in your problems. All right, our last one, a secant and a tangent is exactly the same as two secants, except that the idea of an outside and a whole changes a little bit. So for this picture, AB times AC is equal to AD times AD, which is AD squared. And the way to think about that is it's the outside times the whole is equal to the outside times the whole. It just happens to be that here the outside and the whole are the same thing. Okay, so we're going to do example problems that are going to make this make a lot more sense. Okay, so here will be our examples. And all three are going to need a circle. So take a minute to draw your circles. Then we got to put some numbers on here. That's how we get problems, is there got to be numbers on them. So this will be X, 10, 5, and 8. And then we'll label our other ones. This will be 10, 6, 8, and X. And then our last one will have X, 4, and 6. So now to do these problems, if you don't have the pictures, go ahead and pause it until you get the pictures right. But to do these problems, we're going to look at our formulas. And our formula for two chords said that we basically do this times this equals this times this. So we're going to do x times 10, 10x, equals 8 times 5, which is 40. So we've got 10x equals 40. So x equals 4. And that's it. Easy peasy. All right, example 2. This is a little trickier picture. Remember we said that the outside times the whole. So let's do the blue one first. So the outside is 6, and the whole, which is this, is 16. So it's 6 times 16 equals the outside of the other one. So the outside is 8 times x plus 8. Okay, so 6 times 16 is 96 equals 8x plus 64. And then we basic algebra here. So we get that x equals 4. Right? Not so bad, right? Because if you weren't sure what we did the outside times the whole, the outside times the whole. Now we go over to our last one, and we do the outside times the whole. So we'll do the red one. The outside is 4, and the whole is x plus 4. And that equals to the outside times the whole of the other piece, which is just going to be 6 times 6, so 6 squared. So 4x plus 16 equals 36. subtract 16, 4x equals 20, divide by 4, x equals 5. Not the hardest thing we've ever done, right? So now we're going to do a couple of little more challenging problems. We're going to do 2 of them. We're going to draw some pictures. And we're going to label all of our pieces. So this will be x, x plus 2, x plus 6, and x plus 12. Okay, so same idea applies. We do one piece times the other piece equals one piece times the other piece of the 2 segments. So we do x times x plus 12 equals x plus 6 times x plus 2. So we distribute right here. If we haven't done this in a while, we've got to get back into the swing of this, get you ready for Algebra 2. So x squared plus 12x equals, now we do FOIL. So first, outside, inside, and last. So then we combine our like terms. So we have x squared plus 12x equals x squared plus 8x plus 12. Right, then we want to get all the x's on one side. And so hopefully we see that this x squared and this x squared cancel each other out. And then we just have to do this, minus 8x. So now we have 4x equals 12. We divide by 4, and we come up with x is equal to 3. Again, not super hard, just more involved, more algebra, which is going to be something we focus on a lot more in this last 9 weeks to kind of push you into Algebra 2. All right, one more example. This will be your least favorite. So we're going to have a circle, and we're going to have a secant and a tangent. And we're going to know that this part of our secant is x, this part is 7, and this part is 8. So this is an example of where we do the outside times the whole equals the outside times the whole. So our outside, x, times our whole, x plus 7, equals our outside, 8, times our whole, 8, so 8 squared. And when you first look at it, this doesn't look like that big a deal, right? We get x squared plus 7x equals 64. Well, remember, we want to get all the x's on one side. So we've got x squared plus 7x minus 64 equals 0. Again, not too intimidating, right? We just go try to factor it. The problem with factoring is we're looking for the numbers to put here in a way that they multiply to make 64, so like 8 times 8. But 8 and 8 can never add up to 7. And so we try other numbers, like 32 and 2. Well, that can't add up to 7. So 16 and 4 still can't add up to 7. So no matter what we do, we're not going to be able to factor. Since we can't factor, we have to do something that you probably remember. It's called the quadratic formula, but we haven't done in a while. So hopefully you remember the little song to help you remember this. Remember, we have negative b plus or minus the square root of b squared minus 4ac all over 2a. And the numbers that we use for this, okay, this is the A. So this 1, that's the A. 7 is the B. And the negative 64 is the C. So x is equal to negative 7 plus or minus the square root of 7 squared minus 4 times 1 times negative 64, all divided by 2 times 1. So that's negative 7 plus or minus the square root, and 7 squared is 49. Negative 4 times 1 times negative 64 added to 49 equals 305. And that's all divided by 2. Now you would try to simplify this. You would try to reduce it as best you can. So 305 is 5 times 61. But you can't go any farther than that. So we just have to leave it like this. So this is our perfect, most exact answer. And this is how we want to leave our answer. Now, we can take our calculator and we can do negative 7 plus the square root of 305 divided by 2. And we can do negative 7 minus the square root of 305 divided by 2. And we'll find out that this one equals 5.2 and this one equals negative 12.2. Well, out of those two answers, the 5.2 is a legitimate approximation. The negative 12.2 has to be discarded because we remember we're finding out how long something is. And that segment can't be negative 12.2 long. So this is your approximate answer. This is your exact answer. See you tomorrow.